A. Demonstrate an understanding of a simple regression equation. A simple regression equation models the relationship between one independent variable and one dependent variable. It is typically expressed as y equals a plus bx, where y represents the predicted dependent variable, a is the intercept, b is the slope, variable cost per unit or rate of change, and x is the independent variable. The slope indicates how much y changes for each unit change in x. Simple regression is commonly used for cost estimation and forecasting. In managerial accounting, it may estimate total cost based on activity levels. The intercept reflects fixed cost, while the slope reflects variable cost per unit. Understanding this equation allows managers to separate mixed costs and support planning decisions. Goodness of fit measures enhance interpretation. The coefficient of determination, R superscript 2, indicates how much variation in the dependent variable is explained by the independent variable. A higher R superscript 2 suggests stronger explanatory power, improving reliability for forecasting and budgeting applications. B. Define a multiple regression equation. A multiple regression equation incorporates two or more independent variables. It is expressed as y equals a plus b1x1 plus b2x2 plus bnxn, where each coefficient measures the impact of a specific independent variable on the dependent variable, holding other variables constant. This approach captures more complex relationships. Multiple regression improves predictive accuracy. By considering multiple cost drivers or influencing factors, it provides a more realistic model of business operations. For example, total overhead may depend on machine hours, labor hours, and production runs simultaneously. Interpretation requires attention to statistical significance. Each coefficient should be evaluated using t-statistics or p-values to determine reliability. Multicollinearity between variables may distort results, requiring careful variable selection and validation. C. Calculate the result of a simple regression equation. Calculation involves substituting a known value of x into the regression formula. Once the intercept, a, and slope, b, are determined, predicted y equals a plus bx. For example, if fixed cost is $10,000 and variable cost is $5 per unit, predicted total cost at 2,000 units equals $10,000 plus $5 times 2,000. Accurate calculation supports budgeting and forecasting. Managers use regression-based estimates to predict costs at various activity levels. This helps in preparing flexible budgets and evaluating profitability under alternative scenarios. Results must be interpreted within relevant range. Predictions are reliable only within the activity levels used to develop the model. Extrapolation beyond this range may produce misleading estimates due to structural changes in cost behavior. D. Demonstrate an understanding of learning curve analysis. Learning curve analysis measures productivity improvement over time. As cumulative production doubles, average time per unit declines by a consistent percentage, known as the learning rate. This reflects worker efficiency gains, process improvements, and experience effects. Learning curves are relevant in labor-intensive industries. They are especially important in new product launches or aerospace and defense contracts where initial production costs are high. Understanding learning effects improves cost estimation and bidding accuracy. Learning influences strategic decisions. Anticipating cost reductions helps in pricing strategy, budgeting, and competitive positioning. Managers must incorporate expected efficiency gains into long-term planning models. E. Calculate results under a cumulative average time learning model. The cumulative average time model assumes average time per unit declines at a constant rate. When cumulative production doubles, the average time per unit equals the previous average multiplied by the learning rate, e.g., 80%. This approach calculates new average time and total cumulative time. Calculation involves applying the learning formula. For example, if the first unit takes 100 hours and the learning rate is 80%, the average time per unit for 2 units becomes 80 hours. Total time equals 80 times 2 equals 160 hours. Understanding cumulative versus incremental models is critical. The cumulative model focuses on average time per unit, not just the last unit produced. Accurate calculations improve labor cost forecasting and pricing decisions.